Hey, are you having problems writing chemical formulas? Well, that is nothing to worry about. We're going to take care of that right now. We're going to start off with some easy formulas. We'll just start off with binary, meaning just two elements involved. Hey, let's start off with our classic H2O water. Okay, so if you're going to write water's formula, let's do this in, oh my gosh, look at this pretty color right here. I'm going to call that rust. All right, let's start off with H2O. So first of all, H2O has hydrogen and oxygen. Of course we know that, right? Right, so we're going to start off with H. Always start with the cation, the positive, and H has a positive 1 charge. Now this chart that I have is the one that I gave the class like in the beginning of the year. But if you don't have that chart, just remember we went over this +1, +2, skip the D's, +3, minus, oh it's still here, 0, -1, -2, -3, and then here in the middle, +4, -4, we're not really sure. It doesn't really matter. Okay, so we're going to start off with that. Now this chart has all the nice little charges on there anyway. So we have +1 for the hydrogen, and then oxygen is -2. Right, now really what we're trying to do is make the charges so they're neutral. So we have the same number of positives as negatives. Well, the easy way to do that is just do the old crisscross and take this number here and put it down here, and take this number here and put it down here. So what you would do is you'd write H2O1. Right? And now if you could reduce that, which you can't, but if it was like 2 and 4, you would reduce it. But you can't do that. So you crisscross and then reduce. Now, the ones, of course, are optional. You don't have to write the ones down there. But it just, you know, when we started out, we did that. Let's do beryllium chloride. Right? So beryllium chloride. Right? Okay, let's see here. So beryllium, Be, is +2. Chloride, Cl, is -1. And so 1 and a 2. All right, let's try magnesium oxide. OMG, no, MgO. Right, so we have magnesium oxide. Let's mark that off for you so you know where I'm getting this. Mg and then O again. Okay, so MgO. Mg's first because Mg's +2, right? O comes second because it's -2. MgO. Now, we crisscross and reduce. So those would be 2 and 2, but we're going to reduce that down to a 1 and 1. And we don't even have to write it down, so we're just going to leave it as it is. And that's how you write the chemical formulas. All right, naming these. Naming them is super easy. The cation has its normal name. So let's just name water here for us. So it's hydrogen. And then the anion ends in an "ide" ending. And they're on this chart too, so you can see it, but it's oxide. So hydrogen oxide. Beryllium chloride. Magnesium oxide. Okay, and that's all you do. All right, let's do some polyatomic ions. Now sometimes we have polyatomic ions, and there was a whole chart that we have with polyatomic ions. I'm just going to keep it classic here. We'll go, let's go sodium phosphate. So sodium, you look up sodium, that was Na, right? So Na is +1. And then phosphate. Phosphate is PO4 -3. All right, so sodium phosphate, PO4, and that's a -3 charge. Now, if it's a polyatomic ion, put it in parentheses, and we're just going to treat it like it's one thing. It's an ion, right? It just happens to have more than one element in its ion, but it's still an ion. So what are we going to do? We're going to take a 3 and put behind the sodium. If you want to write a 1 out here, you can. Let's try, let's get something with that bigger charge here. Let's do aluminum sulfate. All right, so let's start this off. Aluminum plus 3, right? Sulfate. Look down here. Sulfite, no, we want sulfate. SO4. Remember, it's in parentheses. And this has a -2 charge, this has a +3. What do? Put a 2 here and a 3 there, and we're done. Okay, that's as easy as it gets, that's it. All right, naming it out, again, the same thing. The name of the element for the first thing, so it's sodium. But then you just use the name of the ion. So you just use the name of the polyatomic ion, so sodium phosphate. Aluminum sulfate, right? Straightforward, nothing tricky. All right, there's one more thing we have to remember. And that is that some elements have more than one charge, right? And it's only the cations, it's only the positives. And so you have to name that and draw it a little bit different. It has the names down here on this chart. You can see it. So you'll have to look for that. But I'm just going to throw some stuff together real quick. Did I have that same chart up here? I do. It's clear. Okay. So I'm going to start off with Fe. I'm going to do both Fe's. And I'm going to just put it with... I'll just put it with sulfate again because we had that right there, okay? So I'll just do, okay, so we'll do Fe. So we have Fe with a +3 charge, and we have Fe with a +2 charge, right? So they're separate ions, right? And we'll put that with sulfate. So Fe with a +3 charge, sulfate has a -2, and so you need a 2 there and a 3 there, right? And then if we have sulfate, SO4, with a -2 and the iron with a +2, this could be 2 and 2, which reduce to 1 and 1, so we don't write anything, okay? And so there's our two formulas. Different formulas because the irons have different charges. How do we name? This is where you need the Roman numerals to name. Okay, and the way we're going to do that is we're going to say iron, and it's the charge. Iron 3 sulfate. And the same thing down here. Iron, it's the charge. Iron 2 sulfate. And that is the stock method for naming. Only when you have multiple charges, and they're on this chart. Look at that, it has it for you. Don't tell anybody. They're on there. So just follow the chart, write what it says, and you'll be fine. Okay, prefix method. If you have covalent bonds, you probably need the prefix method. Let's do water again, that's always fun. H2O, right? Now, so we have 2 hydrogens, so we're going to say dihydrogen. Right? And then we have 1 oxygen, so it's going to be mono, and then we're going to say oxide, because it always ends in that "ide" ending for that last name, so hydrogen monoxide. So you use that. Now, there is one thing, like say if you have carbon monoxide, right, you've heard that name, the mono is optional for the cation. I don't know why they made that rule up. So this is carbon monoxide, right? Not optional for the anion, not optional for this, optional for the cation, the first one. Okay, that should do it for you. Good luck with those. They shouldn't be that hard. And have a nice day.